Okay, so for the second part of our discussion, we'll have the factoring. Okay, so when it comes to factoring, actually it's the reverse process of the special products. Okay, so when it comes to factoring and polynomials, we need to remember that a polynomial with integral coefficient is no longer factorable if we have these two things. Number one, the coefficients have no common factor. Number two, it cannot be further expressed as a product of two polynomials of lower degree. Okay, so I have here eight and forms that we might consider when it comes to factoring polynomials. Okay, so let's start first with the common monomial factor. Okay, so when it comes to the common monomial factor, we need to recall the concept of the greatest common factor, the GCF. Okay, so considering the common monomial factor, so as you can see here, we need to identify its GCF and at the same time the quotient when we divide the given polynomial to its greatest common factor. Okay, and when it comes to the greatest common factor, actually we need to recall the concept of the prime factorization. Okay, we need to recall the concept of the prime factorization. Okay, for instance, we have here 10x squared minus 18x cubed. Okay, so the coefficient 10 and 18, we need to express it using the prime factorization. So we have your 10 as 2 times 5 and then 18 as 2 times 3 times 3 or 2 times 3 squared. Okay, and x cubed can be expressed as x times x squared. Okay, so given this two terms, we need to identify its common monomial factor. Okay, it's greatest common factor. So as you can see here, we can have 2 and x squared as our common monomial factor here. Okay, so we have 2x squared times the quantity of 5 minus 9x. Okay, so as you can see here, 5 minus 9x is the quotient of the original expression when we divide the common monomial factor. Okay, so we have here 5 and then we have here minus 9x. Okay, another example. 60a cubed b raised to 5 minus 105 a squared b raised to 4. So as you can see here, we need to express again 60 and 105 using the prime factorization. So we have here 2 times 2 or 2 squared times 3 times 5 for 60. And then for 105, that's 3 times 5 times 7. Okay, so now as you can see here, we have the common monomial factor as 3 times 5. And we have here a squared and b raised to 4. Okay, so simplifying this, since we have the common monomial factor here of 15a squared b raised to 4, dividing it to our first term, we obtain 4ab. And then 105a squared b raised to 4, dividing it, divide by 15a squared b raised to 4, that's 7. Okay, so as you notice here, you observe uh, the list. Okay, exponent on each variable. As you can see here, a cubed and a squared, that's a squared. B raised to 5 and b raised to 4, that's b raised to 4. Okay, next one. 28 x squared y raised to 4 z raised to 5 minus 42 x cubed y squared z raised to 4 plus 56 x y cubed z cubed. Okay, so again, express it using the prime factorization. We have here 2 raised to 2 times 7 for 28. 2 times 3 times 7 for 42. 2 times 2 times 2 or 2 cubed times 7 for 56. Okay, so now again, let's identify. For x, we need to look at the common monomial factor. Degree for x is x. And then for y, we have here y squared. And then for z, we have here for z cube. Okay, so our common monomial factor here is 14x y squared z cube. Okay, and dividing each term by 14x y squared z cube, we obtain this 2x y squared z cube, z squared rather, minus 3x squared z plus 4y. Okay, another one, aside from the common monomial factor, we have the difference of two squares. Okay, we have the difference of two squares. So as you notice here, as we look at the form, it's the same as the product of the sum and difference of the two terms, right? So as you can see here, if we reverse it, we call that as the difference of two squares. For instance, we have here 9x squared minus 25b squared. Okay, so all we need to do is to apply this form to identify the factors. So as you can see here, since we have here 9x squared minus 25b squared, we need to identify the term here, the first term and the second term here. Okay, so to have that, we need to square root. Okay, get the positive square root of 9x squared and 25b squared. And that's 3x and 5b. Okay, so that's 3x squared, quantity 3x squared minus quantity 5b squared. Okay, so simplifying that, we obtain 3x plus 5b times the quantity of 3x minus 5b. Okay, so as you can see, it's just the reverse process of our discussion earlier. Okay, so aside from this, we have another example, x raised to 4, y raised to 6, minus z raised to 8. You can see here, again, we need to identify uh, the first term and the second term. Okay, to find the factors of this given polynomial. So here in this case, we have x squared y cubed, quantity x squared y cubed squared minus z raised to 4 squared. Okay, so simplifying that, we have the factors x squared y cubed plus z raised to 4 times the quantity of x squared y cubed minus z raised to 4. Another example, x raised to 4 minus 81 y raised to 4. Okay, at first, as you can see here, we cannot identify uh, the factors. But as you notice, it's the difference of two squares, right? It's still the difference of two squares. So as you can see, x raised to 4 can be expressed as x squared squared. And then 81y raised to 4 can be expressed as quantity 9y squared squared. Okay, so if that's the case, we can have x squared plus 9y squared times the quantity of x squared minus 9y squared. Okay, but look at the second factor, x squared minus 9y squared. So as you can see here, we can use again the difference of two squares, right? Okay, so we can express that as quantity x squared minus quantity 3y squared. Okay, so applying again the difference of two squares, we have here quantity x plus 3y and then quantity x minus 3y. Therefore, the factors of x raised to 4 minus 81y raised to 4 is quantity x squared plus 9y squared times the quantity of x plus 3y times the quantity of x minus 3y. Okay, so again, as you can see, as you observe, we use the difference of two squares twice. Okay, to simplify. Okay, to simplify this polynomial. Okay, so always remember, as long as we can identify here uh, forms that we can simplify, uh, we all we need to do is to just apply it. Okay, apply it to get the simplest form. Okay, to get the factors. Okay, of the given polynomial. Okay? So aside from the difference of two squares here, we have the sum and difference of two cubes. Okay, the sum and difference of two cubes. And as you notice, if we identify its reverse, the special product, we can have the product of a binomial and trinomial. Okay, we have the product of the binomial and the trinomial. So for instance, we have your 8x cubed minus 125y cubed. So as you can see, we can express it as the sum and difference of the two cubes. Okay, so all we need to do again is to identify the first term and the second term here. Okay, so get the cube root. Okay, get the cube root of the first term and the second term. Okay, so as you can see here, we have 2x as our first term and then 5y as our second term. So 8x cubed can be expressed as quantity 2x cubed. 125y cubed can be expressed as quantity 5y cubed. Okay, so as you can see here, we have the first term and the second term. So let's apply this form. Okay, so if that's the case, we have 2x minus 5y times the quantity of the square of 2x, which is 2x squared, plus the product of the first term and the second term, 2x times 5y, plus the square of the second term, which is 5y squared. Okay, simplifying this, we'll obtain quantity 2x minus 5y times the quantity of 4x squared plus 10xy plus 25y squared. Okay, so again, as you notice, all we need to do is to reverse. Okay, reverse the rule in special products. Another example, 27x raised to 6 minus 64 b raised to 9. Again, identify the cube root and we'll obtain 3x squared for the first term and then 4b cubed for the second term. So we have here quantity 3x squared cube minus quantity 4b cube. Again, applying the sum and difference of two cubes, we'll obtain this. 3x squared minus 4b cubed times the quantity of the square of the first term, which is 3x squared, plus the product of the first term and the second term, 3x squared times 4b cubed, plus the square of the second term, which is 4b cubed squared. Okay, so simplifying this again, we obtain quantity 3x squared minus 4b cubed times the quantity of 9x raised to 4 plus 12x squared b cubed plus 16b raised to 6. Okay, let's have another example. 64a raised to 4b minus ab raised to 4. Okay, so try to look at this example. At first, we cannot use the sum and difference of two cubes, right? So if that's the case, let's use other forms that might help us to simplify this and identify the factors. So here in this case, let's use the common monomial factor. Okay, we have here a common monomial factor of AB. Okay, so let's factor out AB. We'll obtain 64a cubed minus b cubed. Okay, now, as you can see, we can now use the sum and difference of two cubes. Okay, so if that's the case, we have here again the cube root of 64a cubed is 4a, and then for the b cubed, that's b. Okay, so again, let's use the form ab times the quantity of 4a minus b times the quantity of the square of 4a or the first term. That's quantity 4a squared plus the product of the first term and the second term, which is 4a times b, plus the square of the last term, which is b squared. Again, simplifying this, we'll obtain ab times the quantity of 4a minus b times the quantity of 16a squared plus 4ab plus b squared. Okay, so as you can see here, sometimes we need to use the common monomial factor to recognize the different forms of factoring, such as the sum and difference of the two cubes. Okay. Aside from the sum and difference of two cubes, we have the perfect square trinomial. Okay, we have here the perfect square trinomial. So as you can see here, if you observe, it's again a special product. It's a reverse of a special product, which is called as the square of a binomial. Right? So as you can see here, uh, we can reverse. Okay, we can reverse again to identify the factors. So for instance, we have here x squared minus 6x plus 9. Okay, so let's utilize these forms. Let's have this first form. Okay, so as you can see here, we have x squared, and then we have here negative 6x, which can be expressed as 2 times 3x. Okay, and 9 can be expressed as 3 squared. Okay, so as you can see here, we can utilize the first form, and we have our answer as our factor, quantity x minus 3 squared. Okay, therefore, the factor of the polynomial x squared minus 6x plus 9 is quantity x minus 3 squared. Another example, for x squared minus 12xy plus 9y squared. Again, let's utilize the form. The second term can be the first term can be expressed as quantity 2x squared, and then the second term can be expressed as 2 quantity 6xy, and the 9y squared can be expressed as quantity 3y squared. If that's the case, again, we can use the perfect square trinomial, and we have 2x minus 3y squared. Therefore, the factor of the polynomial 4x squared minus 12xy plus 9y squared is quantity 2x minus 3y squared. Another example, 81x raised to 6 minus 18x raised to 4 plus x squared. Okay, so again, all we need to do is to identify uh, if we can utilize the perfect square trinomial here. At first, we cannot use that, right? But again, let's look at the given polynomial. We can identify that there is a common monomial factor on each term, right? Which is x squared, right? So let's factor out x squared. So we'll have here x squared times the quantity of 81x raised to 4 minus 18x squared plus 1. Okay, so now we can use the perfect square trinomial. Okay, so again, 81x raised to 4 can be expressed as quantity 9x squared squared. 18x squared can be expressed as 2 times the quantity of 9x squared. And then 1 can be expressed as 1 squared. If that's the case, again, we'll have here x squared times the quantity of 9x squared minus 1 squared. Okay, but again, look at this, 9x squared minus 1. Again, we can identify that there is a difference of two squares. Okay, we can identify the factors here. If that's the case, let's utilize again. 9x squared can be expressed as quantity 3x squared. And again, 1 can be expressed as 1 squared. Okay, so by using the difference of two squares, we can identify here the factors x squared times the quantity of 3x plus quantity 3x plus 1 quantity 3x minus 1 squared. Okay, and then we distribute the square here. So our factors now x squared quantity 3x plus 1 squared quantity 3x minus 1 squared. Okay, so again, just observe, there might be the use of the common monomial factor and the difference of two squares. Okay? Another example. 4x raised to 7 minus 8x raised to 5 plus 4x cubed. So as you can see here, at first we cannot use the perfect square trinomial. Okay, so as you can see here, we have the common monomial factor 4x cubed. So the result now here is 4x cubed times the quantity of x raised to 4 minus 2x squared plus 1. Okay, so again, let's perform the perfect square trinomial here. And so we'll obtain 4x cubed times the quantity x squared squared minus 2 times the quantity of x squared plus 1 squared. Okay, so again, applying the form of the perfect square trinomial, we'll obtain this. 4x cubed times the quantity of x squared minus 1 squared. But that is not the final answer. Okay? So observe. As you can see here, x squared minus 1 again is factorable. Right? It's factorable. So if that's the case, again, let's utilize the difference of the two squares. Okay, so we have here 4x cubed times the quantity of x squared minus 1 squared. Okay, and we can express that as 4x cubed times the quantity x plus 1 times the quantity of x minus 1 squared. Again, distribute the square. We have here the factor 4x cubed times quantity of x plus 1 squared times the quantity of x minus 1 squared. Okay, so that's the perfect square trinomial. And actually, we utilize the use of the difference of two squares and at the same time the common monomial factor. Okay, so it's significant for you to observe if there is a common monomial factor. Okay, for us to simplify and identify the factors of the given polynomial. Okay, so aside from the perfect square trinomial, there are other types of trinomials. Okay, so sometimes we cannot express it as the perfect square trinomial. So we need to utilize a new method. Okay, so this type of method actually is a trial and error. Okay, it's a trial and error. Uh, Notice that the sum of the factors of the last term should be equal to the coefficient of the middle term. Again, the sum of the factors of the last term should be equal to the coefficient of the middle term. Okay, so if that's the case, let's have this example. X squared minus x minus 6. Okay, so as you can see here, we need to identify. We need to identify uh, two factors that if we multiply that, it will give us a result of negative 6, which is the last term. And then when we add those two factors, it will result to the middle term. Okay, so for instance, we have here again two factors. If we multiply that, we'll have the last term here. And then if we add, we'll obtain the coefficient of the middle term. For instance, negative 6, the factors of negative 6 is negative 2 and 3. Okay, so when we add that, it will give us 1. Right, negative 2 plus 3, that's 1. So as you can see, negative 2 times 3, that's negative 6. And when we add that negative 2 times 3, plus 3, that's 1. But looking at the middle term here, it should be negative 1, right? So let's try to think of other factors of negative 6. Okay, so it could be 2 times negative 3. So as you can see here, we'll have 2 plus negative 3, which is negative 1. Okay, correction, that's negative 1. Okay, so as you can see here, we have the factors 2 and negative 3. That results to the last term. And then when we add them, we have the middle term, right? So we can utilize that. But actually, since it's a trial and error method, we have different factors that we might consider. But again, it should satisfy the middle term. Okay, so for instance, we have your negative 1 and 6. So when we add them, the sum is 5. 1 and negative 6, the sum is negative 5. So here in this case, we use the second factors, which is 2 and negative 3. Again, correction, it should be negative 1. Okay, 2 plus negative 3 is negative 1. So if that's the case, we can utilize that. We have the factors x plus 2 and then another one x minus 3. Okay, therefore the factors of the polynomial x squared minus x minus 6 is x plus quantity x plus 2 times the quantity of x minus 3. Okay, another example, x squared minus 5x minus 6. Okay, so here in this case, as you can see, again, we need to identify the factors of negative 6. And when we add them, it should be negative 5. Okay, so as you observe, it's almost the same with the first example, right? So as you can see, we can utilize the last one, right? The factor 1 and negative 6. So if we multiply that, that's negative 6. And when we add them, that's negative 5. Okay, that will satisfy the middle term. Okay, so if that's the case, we have the factors now of x squared minus 5x minus 6. That is quantity x plus 1 times the quantity of x minus 6. Okay, so as you can see here, it's actually a trial and error method. Okay, but sometimes the coefficient of x squared is not always 1. Okay, sometimes the coefficient of x squared here is not always 1. What if we have here 2 and so on? Okay, so we have another process for that. Actually, it's almost the same, but we need to consider, of course, the coefficient of our x squared. So we have this form. Okay, so abx squared plus the quantity AD plus BC times x plus CD can be expressed as AX plus C times the quantity of BX plus D. Okay, so for instance, we have your 2x squared plus 9x minus 5. So as you can see here, we have A, B, C, and D. Okay, so as you can see here, the factors of the first term is A and B. And then the factors of the last term is uh, C and D. Okay, so again, observe that AB is the factors of the first term coefficient. And then for the last term, we have CD. Okay, so for instance, we have here 2 times 1, and that's 2, right? That's 2. And then for C and D, let's say aside from 2 and 1, we have 1, 2, right? We have 1, 2. So for C and D naman, we have here negative 1 times 5. Okay, negative 1 times 5. Another one, negative 1 times 5 again. Okay, so here, as you can see, we need to satisfy the middle term. Okay, by multiplying A and D and B and C, and we add them. Okay, so let's see. A times D, so 2 times 5, that's 10, plus B times C, so 1 times negative 1, that's negative 1. So adding that will give us 9. Right, that will give us 9. And then for the second one, 1 times 5, that's 5. 2 times negative 1, that's negative 2. So 5 plus negative 2, that's 3. Okay, but again, we have different combinations here. It could be 2, 1, 1, 2, and so on. And then for CD could be 1, negative 5, 1, negative 5. Okay, so again, it's a trial and error method. And always remember, you need to satisfy the middle term. Okay, so you multiply A and D, also B and C, and you add them. Okay, so as you can see, just like what I've said earlier, we have here the first combination as 9, the second combination as 3, the third combination as negative 9, and then for the last one is negative 3, and so on. Again, there's a possibility, there are lots of combinations here. Okay, but as you can see, at the first combination, we can utilize this to identify the factors. Okay, to identify the factors here. So as you can see here, we have 2x plus -1 times the quantity of x plus 5. Again, you've follow this form. Ax plus c times the quantity of bx plus d. So we have here 2x minus 1 and then another factor x plus 5. Another example. 6x squared plus 7xy minus 20y squared. So again, we utilize this method, but then again, it is a trial and error. You need to identify the factors of the first term, AB, which is 6 here, and then CD, -20 for the last term. Okay, so we have your combination. So actually, you can include the variables here. You can include the variables here to simplify, to identify the factors immediately. Okay, for instance, we have here 6x squared can be expressed as 2x times 3x. For -20y squared, we can express as -5y times 4y. Okay? Another one, 3x times 2x for 6x squared. And then -4y times 5y. Okay, that's -20y squared. So as you can see here, uh, there are lots of combinations, right? But let's focus now on the first one. Okay, since we got it here na. So 2x times 4x, that 4y rather, that's 8y. And then 3x times -5y, that's -15xy. So adding that, that results to -7xy. And then for the next one, 3x times 5y, that's 15y, plus 2x times -4y, which is -8y. So 15xy minus 8xy, that's 7xy. So here, we use the second one. Okay, the second combination rather. Okay. Again, use the form of ax plus c times the quantity of bx plus d. So if that's the case, we have now the factors 3x plus -4y times the quantity of 2x plus 5y. Okay, which is 3x minus 4y times the quantity of 2x plus 5y. Okay, so again, it depends on you on the possible combinations, okay, of the factors of the first term and the last term. Again, you need to satisfy the middle term. Okay, you need to satisfy the middle term. Okay, so as you can see here, we have the coefficient here 9. So we should have the result of 9 here. And then we have here 7xy. We should have the result of 7xy. Okay, so this is the other types of trinomials. So aside from the other types of trinomials, we also have here the factor by grouping. Okay, so sometimes proper grouping of terms is necessary to make the given polynomial factorable. And this is applied usually to at least 4 terms. Okay, at least 4 terms. For instance, factor ax plus ay minus bx minus by. So as you can see here, actually you need to identify a common monomial factor between 2 terms. For instance, we have uh, ax and ay. And the common monomial factor for that is a. And then negative bx, negative by, the common monomial factor is negative b. Okay, so if that's the case, we have your a times the quantity of x plus y minus b times the quantity of x plus y. Now look at this. Again, they have a common factor of x plus y. Okay, so we can regroup this and we'll have a minus b times the quantity of x plus y. Okay, therefore, the factor of ax plus ay minus bx minus by is quantity a minus b times the quantity of x plus y. Actually, you can utilize, let's say, common monomial factor of x and common monomial factor of y. For instance, we have your x times the quantity of a minus b plus y times the quantity of a minus b. So again, we have a common factor here of a minus b. Let's regroup. We have x plus y times the quantity of a minus b. It's the same. Actually, it's the same from the previous one. Right? So it's the different common monomial factor that we use. Okay, another example, ab squared minus 3b squared minus 4a plus 12. Okay, so again, let's identify if there's a common monomial factor between these terms. So here in this case, we have for ab squared minus 3b squared, that's b squared. So b squared times the quantity of a minus 3. And then for a plus 12, we factor out negative 4. So that gives us negative 4 times the quantity of a minus 3. So as you can see here, again, there's a common factor of a minus 3. Let's regroup. So that's b squared minus 4 times the quantity of a minus 3. Okay, times the quantity of a minus 3. But, again, look at this. B squared minus 4 is factorable. Right? It's still factorable. So we can utilize, again, the difference of two squares. Right? The difference of two squares here. So b squared minus 2 squared can be expressed as b plus 2 times b minus 2. Therefore, the factors of the given polynomial is b plus 2 times the quantity of b minus 2 times the quantity of a minus 3. Last example, x squared minus y squared plus 2y minus 1. Since x squared seems to be different among the other terms, we focus on the other terms. Okay, we focus on the other terms. So as you can see here, we can regroup this as x squared minus the quantity of y squared minus 2y plus 1. Right? And y squared minus 2y plus 1 can be expressed again as y minus 1 squared. Right? As y minus 1 squared. Okay? And then after that, as you can see, it's a difference of two squares actually. So that's x squared. And then the second term we can consider here is y minus 1 squared. Right? So if that's the case, we can have this. Quantity x plus quantity y minus 1 times the quantity of x minus the quantity of y minus 1. Okay, so as you can see here, let's simplify. We have x plus y minus 1 times the quantity of x minus y plus 1. Okay, so again, it's advisable to you to be familiar with different forms of factoring. Okay, to have the simplest form and the factors of the given polynomial. Okay, so we have the last two, the addition and subtraction of suitable terms, and the sum and difference of two odd primes. But let's have first the addition and subtraction of suitable terms. This type of factoring is usually applied to polynomials of degree 4, with two terms being perfect squares and both preceded by positive sign. Through the addition and subtraction of suitable terms, the given will always lead to difference of two squares. Okay, it will lead to difference of two squares. So for instance, we have here x raised to 4 plus 4. So as at first, we cannot identify the factors, right? But again, we need to add and subtract a certain term to satisfy this, to identify the factors. So as you can see here, x raised to 4 plus 4, it's actually a part of the square of x squared plus 2, right? It's the a part, the first term and the last term. But we don't have the middle term. So now, add 4x squared and we subtract 4x squared. So x raised to 4 plus 4 plus 4x squared minus 4x squared, right? So as you can see now, x raised to 4 plus 4x squared can be expressed as uh, x squared plus 2 squared, right? And then negative 4x squared can be expressed as minus quantity 2x squared, the quantity of 2x squared. So if that's the case, we can have the difference of two squares, right? We have here the difference of two squares. So we have here quantity x squared plus 2x times the quantity of x squared plus 2 minus 2x. Okay, so simplifying, we have here x squared plus 2x, quantity x squared plus 2 minus 2x. Okay, or we can rewrite that as quantity x squared plus 2x plus 2 times the quantity of x squared minus 2x plus 2. Okay, so here in this type of factoring, you should be familiar also with uh, the square. Okay, the square of given binomial. Okay, so for another example, we have here 4x raised to 4 plus 12x squared plus 49. Okay, so as you can see here, at first, it's not, uh, we cannot factor it, right? We cannot factor it. So as you can see here, as we consider the first term and the last term, we can say that we need to have this quantity 2x squared plus 7 squared, right? Which is the first term for x raised to 4, and then the last term, which is plus 49. But we don't have that plus 28x squared, right? We only have plus 12x squared. So now, what should we add to have 28x squared? And actually, we need to add 16x squared. If we add 16x squared, we also need to subtract 16x squared. Okay, to satisfy the given polynomial. Okay, to for us not to violate any rule. Okay, so as you can see here, we add 16x squared and we subtract 16x squared. And it's still the same polynomial. Now, let's regroup again. Let's combine like terms for x raised to 4. That's correction here for this one, for this line, for x raised to 4. Okay, so 4x raised to 4 plus 12x squared plus 16x squared plus 49 minus 16x squared. And 12x squared plus 16x squared is 28x squared. So as you can see here, we can now utilize quantity 2x squared plus 7 squared. Okay, so again, it leads us to difference of two squares. Okay, so if that's the case, we have quantity 2x squared plus 7 squared minus quantity 4x squared. So we have here 2x squared plus 7 plus 4x times the quantity of 2x squared plus 7 minus 4x. You can rewrite this. You can have quantity 2x squared plus 4x plus 7 and then quantity 2x squared minus 4x plus 7. Okay, so that's the addition and subtraction of suitable terms. Actually, we have your last example. X raised to 4 minus 59x squared plus 25. Okay, so as you can see here, we can have the first term and the last term, right? But the middle term is the will not satisfy any square of two binomials. Square of a binomial rather. So if that's the case, let's say we have your x quantity x squared minus 5 squared, which is equal to x raised to 4 minus 10x squared plus 25. So as you can see, all we need to have for the second term is negative 10x squared. But we have your negative 59x squared, right? So what should be the term we will add and subtract for this? So as you can see, we can add 49x squared and subtract again 49x squared. Okay, and still it's the same as our polynomial. Okay, so x raised to 4 minus 59x squared plus 25 plus 49x squared minus 49x squared. So again, regroup. Combining like terms, x raised to 4 minus 59x squared plus 49x squared plus 25 minus 49x squared. And negative 59x squared plus 49x squared is negative 10x squared. So x raised to 4 minus 10x squared plus 25 minus 49x squared. So again, x raised to 4 minus 10x squared plus 25 can be expressed as quantity x squared minus 5 squared. Finally, we have the difference of two squares. So quantity x squared minus 5 plus 7x times the quantity of x squared minus 5 minus 7x. So we have here x squared minus 5 plus 7x times the quantity of x squared minus 5 minus 7x. We can arrange it. And our final answer, or the factors here, are x squared plus 7x minus 5 times x squared minus 7x minus 5. So that's the addition and subtraction of suitable terms. Lastly, we have the sum and difference of two odd primes. Okay, we have the sum and difference of two odd primes. So as you can see here, of course, we have the restriction in this factoring that the given degree should be prime, odd prime specifically. Okay, and we can express the factors as with this form. Okay, so for instance, x raised to 5 plus y raised to 5. As you can see, it's two odd primes. Right? It's two odd primes. So we can express it as quantity x plus y times the quantity of x raised to 4 minus x cubed y plus x squared y squared minus xy cubed plus y raised to 4. So as you can see here, uh, we have the term x plus y, and we have the factor x plus y. And then for this one, and as you can see, we subtract 1. Okay, in our first term. So 5 x raised to 5 minus 1, that's x raised to 4. And then for the next term, we subtract it by 2, and then the second term. So x raised to 5 minus 2, that's x cubed. And then for the second term, that's y. And then next one, x raised to 5 minus 3, that's 2. And then the second term, you increase it by 1, y squared. So as you notice, as you can see here, the value of x, the degree of x here is decreasing. So from 4, 3, 2, 1, and then 0. And while the second term is increasing. So as you can see here, we have 0, we have y raised to 1, y raised to 2, y raised to 3, and y raised to 4. Okay? Another example, a raised to 5 plus 32 b raised to 5. So as you can see, again, it's two odd primes, the sum and difference of two odd primes here. So we need to identify the fifth root, actually the fifth root of the term and the second term here, which is a and 2b, right? So we have here for the first term as a and the second term as 2b. So we can express that as a plus 2b as one of the factors. Then again, observe. Okay, the first term is the for a raised to 3, a raised to 2, a, and then 0. While the second term increasing. So 0, 2b, 2b squared, 2b cubed, and 2b raised to 4. Okay? And as you notice, when it comes to the terms, the sign is alternate. Okay? Positive, negative, positive, negative, positive. And simplifying that, we have here a times the quantity of a raised plus 2a cubed b plus b squared 2 squared b squared minus a times 2 cubed b raised to 4. Simplifying that, we have this. A plus 2b times the quantity of a raised to 4 minus 2a cubed plus 4a squared b squared minus ab cubed plus 16 raised to 4. Okay? Last example. So we have here 32x raised to 5 minus 243 y raised to 5. Okay, so as you can see now here, uh, we have the fifth root of 32x raised to 5, which is 2x, and then 243y raised to 5, which is 3y. Right? So we have the first factor, which is 2x minus 3y. Then again, for the second factor here, the first term is decreasing, the second term is increasing. So first term, 2x raised to 4, 2x raised to 3, 2x raised to 2, 2x, then 0. Okay, which is 1, just 1. Okay, and then you start here with the degree of 0, which is 1. And then you have your 3y, 3y squared, 3y cubed, 3y raised to 4. Okay, then simplify. Again, so you apply the loss of exponent here to simplify this. And we have now the factor. Quantity 2x minus 3y times the quantity of 16x raised to 4 plus 24x cubed y plus 36x squared y squared plus 54xy cubed plus 81y raised to 4. So again, all you need to do is to apply the loss of exponent here to simplify. Okay, and also it's not necessary that the degree here is always 5. Okay, so it could be 1, 7, and so on. As it is odd prime. Okay, as long as it is considered as odd prime. Okay, so you can refer actually to your module for more examples when it comes to special products and factoring. Okay, there are lots of examples there you can view in our Canvas. Okay, so I'll upload the PowerPoint presentation and also the module. And you have your problem set number 4 for our discussion for today. Okay, I think that's all.